Hi everyone, and thank you for being here. Today I will be represent our project on the 2024 Malaysia Castle. So my name is ALZAM bin Al-Ghazali.
And my name is HAZEEM bin ZAIHAL HAZRI.
Alright, as we know, IoT and the cloud technology are growing very fast. This allows us to track live data in real time. Right now, Malaysia is seeing a huge increase in castle. This creates a IoT of data, which is actually a very valuable asset. By using data analytics, we can turn this raw data into smart, actionable insight. Ultimately, this study aims to analyze 2024 vehicle registration and data connected directly to interactive IoT dashboard. For the objective, to address this issue, we have set four key objectives. First, we want to analyze how brand variety affect total vehicle registration in Malaysia. Second, we want to build a machine learning model, specifically a decision tree to predict field type and use any mismatch to spot unusual records. Third, we will apply anomaly detection to automatically flag the combination of brands, models, and states. And fourth, we want to build and launch a real-time IoT dashboard on TeamSpot to show trends and trigger automatic alarm. For problem statement, next, let's look at the problem statement. We are trying to solve. First, checking and managing huge amounts of the vehicle data manually is just too slow and labor intensive. It doesn't scale well. Second, without analytic, important insight like consumer trends and field preference remain completely hidden. Third, manual check and very hard to detect mistake or duplicate entries, which hurts data quality. And finally, because we don't have a real-time monitoring system, we can get automatic alert when error or anomalies occur. Okay, next we go to Azim.
Hi everyone, today I'm going to be presenting about the graph that we have for our ThinkSpot. First of all, I'm going to be talking about what is ThinkSpot. ThinkSpot is an open source IoT platform. The job is to receive the data from any device from any pipeline in the real time. You can store it and also you can visualize it on the live dashboards. It is used for things like sensor data from smart homes or factories, but any data stream with timestamps works, which is why we could plug our vehicle registrations datasets into it, even though it is not physical sensor. Uh, I'm gonna be telling you how we connect our pipeline to the ThinkSpot. First, we use Google Colab Notebook, does all the analysis, decision tree, anomaly detection, and then send the results to ThinkSpot, which use the HTTP telemetry API. Every device in the ThinkSpot has an access token, which kind of like a password, but we post the JSON data to a URL that includes the token. We batch our uploads in the groups of records per request instead of one at a time, because ThinkSpot has a rate limit, and sending 1,000 individual requests would be slow, and we have the risk of getting blocked by ThinkSpot. So I'm gonna be talking about our dashboard. So this is a few graph in our ThinkSpot dashboard. Um, once the data in the ThinkSpot, once the data is inside ThinkSpot, we build a dashboard with different widgets, each showing something different. As you can see, we have pie chart and also the bar chart. The pie chart, we have the top makers for the car brands in Malaysia, and we have the fuel type distribution. As you can see, the highest consumer users for the fuel type is petrol, which is over 874 users, or we can say 87%. And for top vehicle makers, Pro2 and Proton is the top in our charts. In the bar chart, you can see it shows the total registration per brand, and you can see in the highest form, we can see Proton Pro2 is the highest. Next, we're gonna go to our ThinkSpot. So this is our live dashboard for our CSV data inside the ThinkSpot. You can see a few of what I've shown you in the slide before. You have our pie chart and also our bar chart. We also have a table widget that shows raw row by row data with real time stamps. And we also have value cards which show quick summary numbers like total records that have been processed, which in the dashboard it shows a total of 1,000 data has been read by Google Colab that has been sent to the ThinkSpot. We also have a alarm system, which this the part that make the real monitoring system. It's not just a dashboard. We combine two signals from our analysis into one flag called needs_review. If it's true, if either decision tree's prediction was wrong, or the anomaly detector found something unusual, then in the ThinkSpot, we set up an alarm rule. Whenever the flag comes in a true state, it automatically raises an alarm, so no one has to manually check what's wrong inside the data. If it's asked why combine them into one flag instead of two alarms, it keeps the alarm logic simple. One rule to configure instead of two, and either issue is worth flagging the same way. Since both means the record looks off, someone should check it. It makes the system easier to use. Next, we can go to our Google Colab. Alright, next I'm going to be talking about our result in Google Colab. First of all, what is Google Colab? Google Colab is a free cloud-based notebook environment which we can use and write Pythons. It is basically Jupyter Notebook, which requires no installing Python and no installing libraries manually. It is run inside a browser, which why we use it. It lets all of us write and test code without needing the same setup on our laptop. What our Colab notebook actually does. Our notebook is the engine of the whole project. It is where every pieces of the analysis happens before it reaches ThinkSpot. It runs in order. First, we load the CSV straight from a Google Drive link, which we put the CSV data inside the Google Drive, and then it cleans the data. Our dates were actually formatted inconsistently, so we had to write a logic to fix that. Then it trains the decision tree and runs anomaly detection, and it finally sends everything to ThinkSpot. As you can see from our graph, first we have the decision tree. Second, we have the regression regression graph, and third, we have the anomaly decision boundary. Instead of manually uploading our CSV every time, we wrote a function that takes a normal Google Drive link, the kind that you get from right-click, share, and get link. It converts into a direct download link Python. A direct download link Python can read straight into a table called a data frame that use the pandas library. The data cleaning part, our real problem was the data column have mixed format like 31/12/2024 and so on. If you pass the whole column assuming one format, you get wrong date silently, so there's no error or wrong data. So we wrote a function that tries day first passing first and only falls back to month first, so the specific values don't fit that pattern. And then it runs the analysis. Once the data is clean, Colab run two models, which is the decision tree, which predicts field type and flags any prediction that doesn't match reality, and the anomaly detector flags unusual brand model state combination using a distance calculation. So both of these produce true or false flag per row. And then the last part, of the notebook, it takes our result and sends them to Thingsbot using a Python's request library, basically making a HTTP calls the same way a browser could. But with our data attached, instead of web page requests, we send it to batches, not one row at a time. We send 1,000 at a time. So I'm gonna be presenting how the Google Colab works. So we just have to click the run all, and it will run all the data from our CSV files that we have from our Google Drive, and it will create the graph. Here's the table for our correlation, which is derived memory data set from the raw data, and it will create the plot, and then it will create the regression, linear regression from our CSV data. Next, I'm gonna be showing our decision tree. So in the decision tree, I'm gonna run it. So it's going to get data from the CSV files inside our Google Drive. And then it will create a decision tree classifier. Next, when we're going to the next part, it will verify and import the data. Here's the imported data from our CSV files. And finally, it will generate the decision tree. It will be able to predict fuel, just like I presented. Lastly, we have the anomaly detection. So likewise, I have to click the run all, so it will read the CSV datasheet from our Google Drive. After that, it will import the Python libraries. After the imported data libraries from the Python, it will get the data and create a frequency rate data frame. Here is the frequency rate data frame, and then it's gonna visualize the data. As you can see, I could control from the Google to see in any direction. Alright, next is the Euclidean anomaly detection, which is in this one. And then it will calculate the distance and it will create a histogram for our data sheets. And then it will compute the normalized distance and it will visualize the alarm rate for our CSV datasheets. As you can see, the x-axis have the normalized distance for the Euclidean and the y-axis have the alarm rate. This is the same one. And lastly, we have the decision boundary in a 3D format. Lastly, here is the list of the flag anomalies that is detected inside our CSV datasheet. Alright, that's all from me. I'm gonna pass back to ALZAM.
Thank you, Azim. So now to conclude our framework successfully, turn raw data into a working IoT dashboard. So the implementation of a multi-stage data analytic framework on the Malaysia Vehicle Registration Dataset 2024 successfully transformed raw category records. Our prediction model was highly accurate at 95% in predicting field types. So we also successfully flagged about 8.9% of the transaction as unusual or irregular. So by putting everything together into a ThinkSpot alert system, we now have a highly efficient, automated way to keep our data to clean and accurate. So that's all from us. Thank you so much.
Thank you.